And welcome everyone to LFI Educates. Today we are going to start kinematic, the most important part of the chapter, kinematic equations of motion. From kinematic equations for uniformly accelerated motion. For uniformly accelerated motion. Remember that we are doing for uniformly accelerated motion. There are three kinetic equations for uniformly accelerated motion. The first one we call it as velocity time relation. The second one is your position time relation, and the third one is your position velocity relation. Position velocity relation. These three equations of motion. Here the first one, your velocity time relation, is v equal to u plus at. This is your first equation of motion also we say, or we call it as velocity time relation. The second equation of motion or position time relation is given by displacement s is equal to ut plus half of at square. And the third one, that is your position velocity relation, we write it as v square is equal to u square plus 2as, or we write it as v square minus u square equal to 2as. These three relations are known as the kinematic equations for uniformly accelerated motion. This is L, uniformly accelerated motion. Now let us see one by one how we can derive and get these relations. Let us see first one, the velocity time relation. Here the letters will have to be very familiar. I'll write down once. Here S indicates displacement, V is your final velocity, U is your initial velocity, T indicates time, final time. Generally we take time, starting time as 0 and final time as t. And A indicates acceleration. These are the terms or physical quantities we are going to use to derive the equations of motion. As we know that for a body in uniform acceleration, we get a velocity time graph of this nature, an inclined straight line. We can start from the origin or we can start from any point on the velocity axis as well. For convenience, we will be taking like this only. Let this be AB. For a uniformly accelerated motion, the graph is an inclined straight line. Don't think that why I am not starting from here. You can start, but this one is advantageous. You can derive it easily. That's why I have taken from initial velocity. Suppose it is u. At this point, the initial velocity is u. And when the time is increased from it's t equal to 0 to here it is t is equal to t, time t. Then for this time t, the body's position is at b, suppose. The velocity acquired by the body, we write it as final velocity v. Then you don't have to draw, if I take 2 points like this, I have to draw 2 lines. If I start the graph from here, then I can take only from the topmost point. You can draw the perpendicular, and from A again you can draw one perpendicular. Let us mark this as C, this one as D, let this point be E, so that it will be comfortable for us to do. This A, I'll take it inside. AB is the graph. or the curve, velocity time graph for uniformly accelerated motion. Let us say like this. We'll start this way. Let a body move in a straight line or a straight path with constant acceleration or with uniform acceleration suppose say A is the acceleration here. Also let U be the initial velocity at t equal to 0 and V be the final velocity at t is equal to t. This much you can write down, then you can start doing the derive the equation. Velocity time relation V equal to U plus AT. To get it, we'll start with the slope of the line AB. We know that we'll get acceleration if we take the slope of line AB in velocity time graph. Acceleration A is equal to slope of graph, slope of velocity time graph. So the slope, if you take it, it will be BC by AC. BC, as you know, it is this length BC, that means from D to A. Then it will be DO minus AO, or if you take it here, this part it will be V minus U, final velocity minus initial velocity. You have to subtract it. BC is here V minus U, and AC, if you come horizontally, it is T minus 0, it will be T. So if you cross multiply it, V minus U, here nothing is 1, if you cross multiply it, you will get A into T as AT, or you can write V is equal to minus, if you transpose it, plus U plus AT. Like this you can get the velocity time relation, that is V equal to U plus AT. So simply you have to know that acceleration is equal to slope of the velocity time graph. This is the first equation of motion. Let us see the second one, that is position time relation. There is your S is equal to ut plus half of at square. For position time relation, during the time interval 0 to t, let us assume that the body is displaced by S. Let S be the displacement. During the time interval t is equal to 0 to t is equal to t. Now, as we discussed earlier, that displacement to get the area under this velocity time graph, the area underneath is this one. This is your area, AOEB. That will give us the displacement. Displacement S is equal to area under BT graph, this velocity time graph. So area, if you use the formula here, directly you can take area of trapezium, or you can divide into two parts, area of rectangle plus area of triangle, whichever is convenient for you. I am doing it into two parts, triangle and rectangle. Area, I am writing in short AR of rectangle OECA plus area of triangle ABC. Then you will get area of rectangle length into breadth. Length I am taking it as OE, and breadth I am taking it as OA. This is length, this is breadth. And then in this triangle, half into base into height. Half into base is AC and height is BC. Now if you put the values, OE is T. T minus 0 will give us T. OA is U. So TU or UT, better write UT, plus half of AC. AC is again time T. And you have BC. BC is V minus U. V minus U. Now in this case, UT, we are doing for displacement, this side is S, plus half of T. This V minus U, from first equation, V is equal to U plus AT. From first equation of motion, V minus U is equal to AT. This V minus U, you can put it as AT. Since you can write the reason here, not just putting bracket, since V minus U is equal to AT. Now you get this as UT plus half of A into T is AT square. This gives you the position time relation, or we call it as second equation of motion. The third one, let us see position velocity relation. That is V square is equal to U square plus 2AS. In this case also, you start with the area under velocity time graph that gives us displacement. Displacement S is equal to area under VT graph. Here we'll take it directly so that we can differentiate it from the earlier expression, area of trapezium AOEB, so that you not get mixed up. You can do it, area of triangle plus area of rectangle also, same relation you get it, but just to change it, because it is the next equation, I am taking area of trapezium AOEB. Area of trapezium is half into sum of the parallel sides. If this is a trapezium, AO and BE are the parallel sides. AO plus BE multiplied by distance between two parallel lines. These are the two parallel lines, that is OE. So you can take like this. Then this is half AO, it is U, plus BE, that is V. BE, from top to bottom, vertical line is velocity V, into OE. OE gives you time T. So here, if you use this relation, U plus V into time is equal to V minus U divided by A. From first equation of motion, V is equal to U plus AT. You have V minus U is equal to AT. V minus U divided by A is equal to T. A if you bring down. So I am taking T, since T is equal to V minus U by A. So here what I get is half of V minus U, V plus U will be V square minus U square, using your algebraic identity. Then this side is S, so 2A into S will become 2AS equal to V square minus U square. and u square, if you bring this side, it will become plus, minus will become plus, and you get the relation v square is equal to u square plus 2as. This is your position velocity relation, or we call this third equation of motion. This is how you can get it graphically. Now let us discuss about position of the particle in the, how to find out position of displacement of the particle in the nth second. Here nth second means in that particular second, 5th second, 6th second or 7th second, in that particular instant of time. How you can find out the displacement? Let us see. We have formula for this. To find the displacement of particle in the nth second, we subtract the position of the particle in n minus 1 second from the position of the particle in nth second. Like this, from nth second, if you subtract the position of the particle in n minus 1 second, n minus n, minus to minus will become plus 1. In that particular second, you can find out the position or displacement of the particle in the nth second. So to start with, we'll do like this. Displacement of the particle in the nth second. We'll do position of the particle in nth second minus position of the particle in n minus 1 second. That is equal to, I am writing here, displacement in the nth second. Your formula for displacement is s equal to ut plus half of a t square. But in nth second you are finding out, so time you take it as n, un. Here also it will become n, a n square. This way you write down. Minus, here also same way, ut, time is now n minus 1 plus half of a t square, n minus 1 square. Like this you write down. You use the formula for displacement. Then un plus half of a n square. Then open the bracket, minus un. Minus into minus will be plus, u into 1 will be u. Then here you have plus, minus into plus is minus, half of a n minus 1 square. Like this, you write down first. Then this un term you can cancel it out. This odd looking term u you write first, plus from this term and this term, if you take a by 2 common, then you will get like this, n square, and here minus a by 2 you took common, so n minus 1 whole square. So it will become u plus a by 2, so n square, minus is there, so a minus b whole square is a square minus 2ab plus b square. 1 square is 1. then this is u plus a by 2 n square minus, this is n square, minus into minus is plus 2n, minus into plus is minus 1. This n square, if you cancel it, you get a displacement of the particle in the nth second. That can be written as, this line I am writing the n line here, u plus a by 2 2n minus 1. This gives us the displacement of the particle in the nth second. With non-uniform acceleration, we use the equations of motion like our earlier wave. X represents position, then velocity to find out. We'll be using this v is equal to ddt of x. So calculus way you'll have to use it to deal with bodies with non-uniform acceleration. And acceleration to find out, we'll have to differentiate velocity dv ddt of v or dv dt. Then we'll get acceleration. So let us do one question, and the reverse is also true. When acceleration you know, if you integrate it, integral calculus you have to use there, then you will get velocity, and when this velocity will be integrated, then you will get position. The integration formula is like this. This one you will have to know. Integration of integral calculus. Integral calculus is for summing up all the particles. If we add them up together, then we will get a bigger quantity. That we call this integration. This symbol like small big S used to write long one like this S. This is x to the power n dx. This is the first formula that we'll be using. This is equal to x to the power n plus 1. In differentiation it becomes minus, in integration to become plus, and this n in integration differentiation it comes here multiplication, and here it will come out as division, but here you have to add 1 plus a constant term c will form, because as it is a reverse of integral calculus is a reverse of differential calculus. In differentiation, constant term, if you differentiate it, it is 0. So here it does not appear that constant term. So the constant, when you change from differential to integration, then you have to add up this constant term plus c will come. So here is one question. Let us try to solve it. Like this, the question says, two particles move along x-axis. The position of particle 1 is given by, for first particle, the position is given by, let us write it as x1 for the first particle. It is 6t square, 0.00, if you don't write also it's okay, plus 3t plus 3t plus 2. This is the position of the first particle. The overall value is in meters and time is in seconds. Acceleration of particle 2 is given by A. This is for particle 2. For second particle, acceleration, let us write A2. It is minus 8t. This is the acceleration given for the second particle. And at t equal to 0, its velocity is 20 meter per second. And velocity of the second particle is given as 20 meter per second at t is equal to 0. Now, when the velocities of the particles, means for the first and second particles match, find their velocities. So now what you will have to do is, this position will change it into velocity, this acceleration also will change it into velocity, and then we'll equate them. both of them, then we'll get their velocities individually. Let us see one by one. For the first particle, velocity of the first particle, velocity of the first particle, let me write it as v1. v1, to get it, I'll have to differentiate x1, ddt of x1. ddt of x1, if I do, then I'll get the velocity. This is ddt of x1 is 6t squared plus 3t plus 2. So on differentiation, I'll get 6 2s are 12t plus 3 plus differentiation of 2 will be 0. So it will be 12t plus 3. v1. Let us mark it as equation number 1. This is for the first particle. Now, from the acceleration of the second particle, we'll get the velocity. To get velocity from acceleration, we'll have to integrate it. So, to get velocity of the second particle, now you will be thinking that there is already given velocity of the second particle, but it's not given in terms of t at t equal to 0. This is to find out the integration constant they have given to you. To find out the velocity of the second particle, v2, to find out, you'll have to integrate this acceleration. Acceleration is a2 dt. With respect to time, you have to integrate it. When you integrate it, a2, you'll get, what is the value of a2? You put it minus 8t dt. Now to integrate it, minus 8 you can take outside. This t power is here 1. So it will be t to the power 1 plus 1. We'll add it. 1 we'll have to add it. And downside 1 plus a constant term will come. Now this constant term, if I rewrite it like this, will look, this is v2. I'm writing here v2. v2 is equal to minus 8t squared divided by 2 plus c. So at t equal to 0, v2 is given 20. So putting the values t and v2 value, we will get c. After getting c, we will get the expression for velocity. At t is equal to 0, v2 is equal to 20 meter per second. So let us put it here. v2 is 20 is equal to minus, this one 2, 4 times is 8, so minus 4t squared, t is 0, plus c. So from here you can find out, this one I'll keep as it is, this one 20, this is 0 plus equal to c, After getting the value of c, if you put it back here, then you will get the expression for velocity v2. So v2 is equal to minus 4t squared plus c, it is 20. This will be equation number 2. Now according to the equation, velocity v1 and velocity v2, when they are equal, here is given when the velocities of the particles match, then find their velocities. So we'll equate equation 1 and 2 as per equation. As per equation, v1 is equal to v2. So if you put v1 is equal to v2, v1 value is 12t plus 3 is equal to v2 is minus 4t squared plus 20. So we'll calculate it now. You'll get a quadratic equation. T squared is there, you can see very clearly. So this one, if I bring here 4t squared, minus will become plus plus 12t plus 3 minus 20 is equal to 0. So it will be 4t square plus 12t. 20 minus 20 plus 3 is minus 17 equal to 0. Here a quadratic formula you can use. B equal to 12, C is equal to minus 17. So T will be minus B plus or minus root over B square minus 4AC divided by 2A. This is a quadratic formula. Minus B. B is 12 plus or minus B square is 12 square minus 4 into A is 4 into C is minus 17 divided by 2 into A is 4. So this is minus 12 plus or minus 12 square is 144. Minus into minus will be plus 4 4s are 16 into 17. You can multiply 7 6 are 42, 7 4 11, 6 1 2 7 2. 272. Then add 144. 6 11 1 1 in hand 3 4. This is 8 minus 12 plus or minus total 416 divided by 8. On finding out the square root, 416, if you find out the square root, 2 digit, 1 digit, 2 2s are 4, 1 6 plus 2 is 4. You cannot do even one time. 41 it's much smaller, so what you will do is put 1 0 as you cannot do. Here also 1 0, and here 2 zeros, then here 1 decimal will come. For 3 times will come out, I think 9 0 4 3 6 12. Let us see 4 0 4 times 16 16. This will be bigger than this, so 3 will take it. 3 it is 1 2 0 9. It is minus 12 plus or minus 20.3 divided by 8. Now let us calculate T is equal to minus 12 plus 20.3 divided by 8, or T is equal to minus 12 minus 20.3 divided by 8. So T is equal to, if you subtract 12 you will get 8.3 divided by 8, or T is equal to minus 32.3 divided by 8. That's 1.04 if you round off to 2 digits after decimal. T, or T is equal to minus 8 4s are 32 point, here also 3, so ultimately it will be 0.4, but T cannot be negative since time cannot be negative, therefore T is equal to 1.04 second will take it. Now after you find out the time, you have to find out their velocities. What was V1? That we have to know. V1 and V2 both are equal, therefore V1 is equal to 12t plus, so if you take 12 into 1.04 plus 3, then you will get 1.04 into 12. 12 4s are 48, 12 1s are 12. It is 12.48 plus 3. It will come nearly 15.48 meter per second. V2 was minus 4t square plus 20, most probably. Minus 4t square is 1.04 square plus 20. It will be minus 4 into 1.04, 1.04, 4 4 16, 4 0 is there, 1401, 61801. After decimal 4 digits into minus 4. 6 4s are 24, 4 is 4 5 6, 8 4s are 32, 4 is 4. 4 digit, it will be minus 4.3264. If I round off to 2 digits, it will become 3 plus 20. Then 20 minus 4.33. 10 minus 3 is 7. 9 minus 3 is 6. 9 minus 4 is 5. 1. So it will be 15.67 meter per second. You can see here they are very close to each other. So V1 is equal to V2 when t equal to 1.04 seconds. Thank you and have a nice day.